So, all of you know that the history of power systems goes back to late 19th century. Towards the end of the 19th century itself, there were many power systems. So, not that the DC system or the DC transmission using power electronic circuits was, I mean, was not there, of course, at that time because power electronics came much later. But there was DC and AC at that time. Okay, so there were many instances of use of DC for transmission, even if the system was predominantly AC. There was a system by name Curry system. Now, this is actually a DC transmission system which was used in Europe in the early 20th century. So it was actually designed by a French engineer by name Tari. Tari is the name of the French engineer who designed this. So what does this system contain? Actually, this system had DC generators which generate power in series. DC generators connected in series. So all the armatures of many DC generators are connected in series. Now the purpose is to get a high voltage. See, for transmission we need high voltage. See, the main limitation of DC, of course, why we went to AC is, AC provided a means to transform the voltage from a lower value to a higher value using transformers. That was the reason we went from DC to AC. So there were some parallel developments in DC also, in Europe especially. So if I connect many DC generators in series, then I get a high voltage. Then at the consumption end also, I have many DC motors which are connected in series, and then these DC motors actually drive generators which can be used for consumption. So this was one system which was popular in Europe for some time, but this didn't last long because DC machines have some limitations. Of course, there are always limitations with DC machines, whether it's motor or generator. So just for the sake of completeness, I mentioned this. But after this, there were other DC systems. See, I'm talking about an era where there was no semiconductor, there was no thyristor, diode, or IGBT or GTO thyristor, and so on. So there was a time when we used what is known as mercury arc valve. So a mercury arc valve is one particular device which can be used to build a circuit which is similar to the rectifier or inverter that we are familiar with now. Okay. So there were many HVDC transmission lines using mercury arc valve. So the very first DC transmission line was in 1954, was using mercury arc valve. Now the thyristor based transmission started only in 1972. So from 54 to 72, there are a large number of converters that were actually commissioned using mercury arc valves. Of course, there was a mercury arc valve based converter which was working till 2011. Of course, as of today, there is no converter which is using mercury arc valves. So either we have thyristor based or the more advanced ones which are actually voltage source converter based. So the voltage source converter based DC transmission is more recent, and it started with the development of high voltage, high current IGBT. So if you look at the development, what started initially as a Tari system, which didn't have any particular circuit of a converter, it just used motors and generators. Then that was followed by a circuit using mercury arc wells. Then we had the thyristors, now voltage source converters. But the point to be noted is the voltage that is required for transmission is of the order of hundreds of kilovolt. Now there is no single device which is rated for hundreds of kilovolt. So if you look at a thyristor is rated for at most say 12 kV. Okay, we have thyristor rated for 12 kV, and of course even the IGBT, which is used for building a voltage source converter, does not have a rating which is more than a few tens of kV. Okay, so we have all these are limited to at most 10 kV, the voltage rating. Of course, we do have current ratings. Current ratings of the order of kiloamps is available. So in the early days, when thyristors were used for DC transmission, we used to construct a circuit like this. Suppose if you are familiar with the symbol of a thyristor, suppose I want a device with a very large current rating. So what I do is, a single device cannot carry that large current, so we connect many such things in parallel. Now, if I don't have the required voltage rating, what I do? I connect many such devices in series. Now, if you look at the very first thyristor based DC transmission, neither the current rating was available nor the voltage rating was available. So at that time, what was done? We used both series as well as parallel connection. So there were many thyristors connected in series. And many such circuits connected in parallel. So this particular circuit, having a large number of thyristors in series and many such series connections in parallel, was given a name. The name was valve. So we use the word valve, or to be more precise, thyristor valve, to mean a large number of such thyristors connected in series and such circuits connected in parallel. But nowadays we do have the current rating, so we no longer need the parallel connections, but we still need the series connection. So as I said, if I have the maximum rating available as 12 kV, if I want say 500 kV, so the minimum number of thyristors that I need to connect is 500 divided by 12. Okay, so we still don't have a thyristor device which can withstand the voltage level at the transmission. Okay, so at the transmission voltage is hundreds of kV. So 500 kV is an example. So right now we don't need parallel connection, we need only series connection as I have shown here.